Hey guys, in today's algebra video, we are going to look at how to recognize the graphs of piecewise functions. So the function that I have graphed up on the screen here is clearly not made of just one equation, right? It's part parabola, part line. So that's a piecewise function. It's a function that has different function rules used depending on what the x value is. So for different intervals of the domain, there's a different rule that tells us what the output is going to be. So the first order of business is to figure out what two equations were used here, right? And it could be more than two, but here I see that I have only two equations used. So to make that parabola that's on the left side, I clearly use the equation y equals x squared, right? It's a parabola that goes through the origin. That's y equals x squared. Now, I don't see the whole span of that parabola. It does stop somewhere. So this is the second most important part, is determining what is the domain. I'm graphing this parabola from where to where. So on the left side, it goes up forever as indicated by this arrow here, right? But on the right side, it does stop somewhere and become a line. So we have to recognize where that stops. Let's zoom in a little bit. And we look for this point right here, which is the point 1, 1. That's the point at which that parabola all of a sudden turns into a linear function. So that means that when we graph this parabola y equals x squared, we're not graphing it for all values of x. We're only graphing it for values of x that are less than 1. Because all the values over here, so this is, let's say, 0.5 for x, 0 for x, -1 for x, all those x values that are less than -1, they have a corresponding y value that came from the equation y equals x squared that created a parabola, right? But that doesn't happen going to the right of 1. So if I graph, for example, if I was going to use y equals x squared and substitute an x value of 2 in there, I would get 2, 4. But 2, 4, 2, 3, 4, 2, 4 is not on this graph, right? 2, 4 would have been part of it if I extended that parabola up, but I don't. That parabola stops at 1, 1. Okay, so the way that we show that is the way that I wrote it over here, showing that the equation y equals x squared is used, but only for x values that are less than 1. The other important piece of this is knowing whether or not that 1 is included as an x value. So when we zoom in again, we see that that point 1, 1 has an open circle on it. That means that it's the limit, but it's not included. So we have to use the inequality symbol less than, not less than or equal to. And let me erase that so you don't think my underlining is an or equal to. All right. So had that point been shaded in, had that point been a part of this function, then we could say that we're using that equation for all values of x that are less than or equal to 1. But that open circle right there means we're using the inequality x is less than 1. Okay. So that's the first part of my drawing I have up here. The second part is a line. So now again, we need the equation before anything else. Let me just erase this a little better, sorry. Okay, we need the equation before anything else, and we're looking at that line for all values of x that are greater than 1 now. So remembering how to find the equation of a line, we're looking for the m and the b, right? We want to know our slope and our y-intercept. So the y-intercept is not clearly visible from this graph, but obviously we can find it algebraically. So let's find our slope first. Let's pick any 2 points that are on this line, and we can start with the point that's open, but I'll just choose these 2. So assuming that these units are going by 1 since there's no label, we're going to find our slope by doing rise over run. Our rise is 1. Our run is 2. So our slope is 1/2. Okay. And now if we take any one of those points, let's say 1, 2, 3, this over here was the point 3, 2. So now to find our b, we can do some algebra. I'll do it in blue on the graph. We can take this point b, right, that has our x, y. Sorry, that's not our point b. We're trying to find our b. And we're going to substitute into y equals mx plus b. So let's substitute y with 2, right? I'm getting that from right here. Equals, my slope was 1/2. My x is 3 in this case. And my b, I don't know. I'm trying to figure out what the y-intercept is. All right. Now we're just going to evaluate over here. 3 times 1/2 is 1.5 or 1.5. So 1.5 plus b equals 2. I'm going to subtract 1.5 from both sides, and that's going to give me 0.5 equals b. So as you should remember from your linear functions unit, once you have your b and you have your m, we can just write the equation of the line as y equals 1/2 x plus 0.5 or plus 1/2, right? Same thing. Okay, now that I have the equation of the line, If I look at my answer choices, I realize that only answer choice number 2 has both correct equations, but we still want to make sure our domain is correct, because if it's not, maybe we made a mistake writing our equation. So this line, again, I'm not seeing it for the whole span of the graph, right? This line starts at this point or immediately after it, and then on to infinity to the right, but it does not go this way on the graph. So we only want to see that line for the x values that are bigger than 1. So remember that point that we highlighted before for the parabola, that same point, which was 1, 1, is where the line starts as well, right? But again, that point was open, meaning that 1 is not part of the domain. So we're looking at all the x values that are bigger than 1. So when x is bigger than 1, I use the equation of the line to draw that graph. When x is less than 1, I use the equation of the parabola to draw that graph. Okay? Let's go through a different example. All right, which graph represents f of x equals the absolute value of x when x is less than 1, or the square root of x when x is greater than or equal to 1? So you have your graphing calculator, or you can just plug in some values, or you already know what these graphs look like. But we know that we want to graph the absolute value of x when x is less than 1. So absolute value, we know graphs as a v, right? But we only want to see that graph when x is less than 1. So if I picture, say this is a 1 here, I'm going to kind of picture it like I'm cutting it off after that. So I only want to see that graph when x is less than 1. So all the values of x that are greater than 1, and I shouldn't have erased that whole thing, sorry, those are all going to be gone. Okay, so that's the part of absolute value of x that I want to see on this graph. And if I look at my answer choices just to see if we can eliminate, you see that we can eliminate 2 answer choices right away just based on that part of it, okay? And that's going to be 3 and 4. Those are gone because they, if I zoom in, you'll see they didn't graph v's, they graphed curves. So this part of the piecewise function, they use y equals x squared to make that curve, right? That's not y equals absolute value of x. All right, so going back to our 2 answer choices that are possible, let's figure out which of them is correct. So now the other part of it says that, okay, that's what happens when x is less than 1. So for all my values on the graph where x is smaller than 1, so when x is 0, when x is any negative number, I should use the absolute value of x. We can prove that this is right on the graph by just picking any point. So if you pick a point like -5, right? -5 satisfies this inequality of being less than 1. When x is -5, y is supposed to be 5. So if we check on our graphs, 1, 2, 3, 4, -5, 5 is on both of these graphs, okay? Now we want to see what's up with this second equation. Which one graphs that one correctly? So the square root of x. Again, you can throw this in your graphing calculator. You can just substitute some values in to figure it out, or you may just know offhand what that graph looks like. But if I'm looking for the square root of x when x is greater than 1, I can start by choosing 1 as my value. So if x was 1, well then if I input 1 into the square root of x, I get 1. So 1, 1 should be a point on this graph. And as you see, 1, 1 is a point on both of these. So we need to go further. So if I pick 4 for my value of x, well, if x is 4, then the square root of 4 is 2. So 4, 2 should be on my graph. 1, 2, 3, 4, 1, 2. This is indeed the graph of the square root of x. So you'll see that from the value of 1, going on to infinity, that graph is going to give me the graph of square root of x. But everything less than 1, it graphed the absolute value of x. All right, so that is how you recognize the graphs of piecewise functions.